Okay, so let's continue with number 2. So we have here g of x equals x squared minus 9 all over x squared plus 2x plus 1. Okay, so let's continue. So to find the vertical asymptote, let's equate the denominator to 0. So you have here x squared plus 2x plus 1 equals to 0. Now remember that this one is a perfect square trinomial, so we can factor it as a square of binomial x plus 1 quantity squared then equal to 0. So we can take the square root of both sides. We get x plus 1 equals to 0 and x equals negative 1. So we have a candidate for asymptote x equals negative 1. Now let's try to evaluate the one-sided limit of the function at negative 1. Okay, so let's write limit as x approaches negative 1. So it's either from the right or from the left. So let's use from the left, but you can use also from the right. So you have here x squared minus 9 all over x squared plus 2x plus 1. Now for convenient purposes, we can factor this one out. X squared minus 9 limit as x approaches negative 1 from the left. Remember that if you're still not evaluating the limit, you should always write the limit notation. So here you have x plus 1 quantity squared. Okay, so applying the limit, you have negative 1 from the left squared minus 9 all over negative 1 from the left plus 1 quantity squared. So above you have 1 minus 9. It doesn't really matter. For this one, negative 1 from the left is negative 1.01, which is greater than 1. So therefore, if you try to subtract it, what you will have is negative 1.01 plus 1 is negative 0.01. So that is around, that is actually 0 minus, then squared. So negative 0.01. Of course, 1 minus 9 is negative 8, and a negative 0.01 or 0 from the left. When you take the square of that, you will get a positive number, of course close to 0. Now it becomes a positive, so it's 0 plus. So negative divided by positive, you will get negative infinity. Anyway, it doesn't really matter because our target is whether you get the infinity an infinity answer for this one or not. So therefore, we get the infinity answer. Therefore, the x equals negative 1 is a vertical asymptote of the function. Next is the horizontal asymptote. So let's try to approach it at infinity. So limit as x approaches infinity of x squared minus 9 over x squared plus 2x plus 1. So again, using our rule in infinite limits, this one is x squared over x squared, or this is limit as x approaches infinity of 1, which is just equal to 1. So therefore, y equals to 1 is a horizontal asymptote of this function. Okay, how about the slant asymptote? So again, the numerator degree is 2. The denominator degree is also equal to 2. If you try to subtract them, you will get 0 again, which is not equal to 1. Therefore, the function has no SA.